triangle, here we go. The area of a triangle is going to be, watch this now, area is 1/2 base times height. There's the formula. The rest after the second equal sign is just how to say it. 1/2 base times height. They tell you how to say the formula, okay? So I left this formula sheet for you, for your own reference on C42. Here's the formula, base times height. So let me write the formula right here underneath the triangle. Area equals 1/2 base times height. All right. What is the base and what is the height? That's the question. What would be the base? 12, huh? The bottom side. So watch this now. 1/2 times 12. I'm separated by parentheses because that communicates multiplication. The height is going to be, watch this now, the height is always going to be 90 degrees with the base. So whatever you see connected to the base that's 90 degrees, that's the height. So the height is going to be 10. Look at that. 1/2 base times height. So here we go. 1/2 base times height is going to be, watch this now, 1/2 times 12 is the same as 12 divided by 2. So 1/2 times 12 is just 12 divided by 2, which is going to be 6. 6 times 10 is going to be 60. So the area then is going to be 60 square units. Remember, I had you cut out the square inches yesterday? But here on this example, we didn't specify whether this is 12 inches, 12 feet, 12 miles. It's just 12 and there's 10 and there's 13. So if that's the case, what you do is you just write the word units, which is communicating, hey, look, whatever it's measured in, whatever units it's measured in, whether it's inches, feet, miles, we just write the word units because we didn't specify on this problem whether those are inches or centimeters or anything. They're just numbers. So we have to write the word units. But what kind of units? It's area, so it's square units. Because remember, area is the inside of a shape, the squares that fit inside. Awesome. So, let's do the perimeter now though. That's just area. Remember, perimeter is the outside? The perimeter then is going to be all the sides added up. Come on now. The perimeter is just 10 plus 12 plus 13. Which is going to be 22 plus, what does that become? Sounds good to me. 34 units. Because notice, they didn't specify whether this is inches, or we just write the word units. 35? My bad. Coffee time, coffee time. 35 units, but notice they're not square units, they're just normal units because square units is only for area, the two-dimensional space. Perimeter is just one-dimensional distance around the shape. One-dimensional distance, just the distance around, therefore it's units only. Awesome. While I play this day in history, bust out your notes from yesterday, the 2 vocabulary words, the area perimeter notes. I'm going to go over a few examples, and then you're going to do your table talk activity together. Get those out from yesterday, please, while I play this day in history. Find area and perimeter of the trapezoid. The formulas?
Yes.
I'm going to do that right now. I got you. I'll put the formulas up right now. Again, it's on C42. Let's go, Gabriel, I got you. Trapezoid. Okay. What are my bases and what's my height here? So let's see. Here's a formula right here. Right there. Everything after is just how to say the formula on this table. 1/2 sum of the bases times height. They're just showing you how to say this formula. Okay, the formula is just everything after the first equal sign and you're done. Don't get confused there. A lot of students get confused with this thing. That's the formula right there only. After the second equal sign, it's just a way of saying the formula itself. So let me write the formula down. Here we go. Area then is 1/2. B sub 1 is the first base, plus B sub 2 is the second base, times the height. That's not B to the first power and B to the second power. That means B sub 1, B sub 2. That means the bases. And on a trapezoid, the bases are just the sides that are always parallel. Look at this side and this side are parallel. They'll never intersect. They go the same direction. Those are the bases of a trapezoid. So the 15 and the 20 are the bases, the B1 and the B2, the bases. And the height is always connected at 90 degrees with one of the bases. So whenever you see 90 degrees, you know that's the height. Whether you're dealing with a triangle, because look at a triangle has height, look at a triangle has a height, the H. Parallelogram has a height, there's a H. And so does a trapezoid, here's your height, the H. The height is always connected at 90 degrees, look at 90 degree angle, with the base. If you're ever wondering where your height is, look for a 90 degree angle with the base, and that's your height. So 8 feet is going to be your height. And that goes for any shape that has a height. You're looking for 90 degrees with the base. Here we go. Area then is 1/2. The bases are 15 and 20. The height is 8. We got to do what's in the parentheses first. That's from junior high school. Please excuse my dear Aunt Sally. The P stands for parentheses. Very good, Quintero. So here we go. The area then is going to be 1/2. 20 plus 15, I want to say is 35, times 8. So I'm multiplying now, so I'm just going to go left to right. 1/2 times 35 is the same as 35 divided by 2, which is going to be 17.5. So all I did, 1/2 times 35 over 1 is the same as 35 divided by 2. 35 divided by 2 on a calculator is 17.5. Now 17.5 times 8, let me get my calculator out here. 17.5 times 8, 140. 140 what though? Chickens, horses, termites? What? 140 what? It would be units, very good, if it wasn't specified, but they're specifying that everything is being measured in feet, so the area would be in what? Square feet, huh? Yesterday you guys cut out a square inch. Now the area here is 140 square feet. So area is always in square units. Nice. Let's find the perimeter now. The perimeter I'm gonna put in green. Going away right now. Check it out. The perimeter. Here we go. 10 plus 10, that's the two sides here, plus 15 plus 20. Perimeter is easy. There's no formula, there's no special formula for perimeter. Just add up the sides. So perimeter then is 20, 40, so I got 55. 55 feet, not square feet, just normal feet. The distance around the trapezoid is 55 feet.
Mister, what's the area?
140 square feet. Notice how it's square feet because we're dealing with area. Perimeter is just normal feet, the distance around. We got to get that right. So we're going to find the area and circumference, but let me, before I use the area formula for a circle, which is pi r squared, let me show you what pi means.
Circle, if we start at the top and wrap the diameter around the circumference, we see that one diameter is not enough to go all the way around.
Okay, one diameter in green. Okay, let's get another diameter now.
So let's get another
Yellow
diameter
one.
and keep going where the first diameter stopped. Two diameters still isn't enough to go all the way around. It looks like we're going to need to get a third diameter and keep going.
There's a pink one now.
Oh!
But it's not completely around now. It's 3 diameters plus a little bit more. This goes for any circle you draw. This is a mysterious thing about the diameter. It takes 3 point, how many?
So close! 3 diameters is almost enough, but it looks like we're going to need just a little bit more to form a full circumference. That little bit more turns out to be about 0.14 diameters.
That's where it comes from. No matter how big or small, it's 3.14 diameters around the circle, yes.
So the diameter is half of the full circle?
No. The diameter is the distance from one end of the circle to the other that goes through the center. The circle itself, so what you're thinking, the circle itself, Miss Quintero, the circle itself is just this right here. Just that distance. Inside the circle, that you're talking about area. I think what you're trying to think of is, look, the diameter cuts the area of the circle in half. Yeah, I like how you're thinking. I like that. But pi is only 3.14 to the nearest hundredth. You want to know how long pi is, the number? I do. Watch this. Maybe not. Pi. How big is pi, the number? Look at there. It keeps going though. Look at that. Look at 3.14. 3.14, blah, blah, blah. It just keeps going. It's kind of a mysterious number. It keeps going. It's an infinite, non-repeating decimal. Does it ever end? God knows. But it is a very strange number, mysterious, and we use it all the time in engineering. Let's go back over here. So that's what pi is, 3.14 to the nearest hundredth. We can get more exact if we wanted to. There we go. So how many square centimeters fit in this circle? Let's rock and roll. Here we go. Area of a circle then is now, watch this now, since I'm going to replace pi with 3.14, that's only an approximation of pi. I just showed you that pi is an infinite non-repeating decimal. So I'm going to use 3.14, that's an approximation. I'm rounding off to the nearest hundredth. Therefore, I'm going to change that equal sign to approximate. 3.14 times the radius is 11, I'm going to take that puppy to the second power. Area then is 3.14. Oh, by the way, I have decisions to make. Aunt Sally, please excuse my dear Aunt Sally. Does Aunt Sally say to multiply first or do the exponent first? I got decisions to make. Exponent or multiply? Exponent comes first. So this is going to be 3.14. 11 to the second power is 11 times itself. Not 11 times 2. Please be careful. 11 times itself is 121 if my coffee is kicked in. By the way, this is good coffee. Need some more, actually. 3.14 times 121. Let me get my calculator out. Questions so far? I trust I'm not going too fast. There we go. 3.14 times 121. Oops. 121. 379.94. Watch this now. area is approximately 379.14 what? Chickens, horses, or termites? What are we counting here for area? What kind of units? So what kind of centimeters though? A square centimeter. Squares. That's how many square centimeters would fit inside the circle. Remember the two-dimensional space of the circle. So we're going to take this circle, let me drag the circle down here. While you're writing that down, let me drag the circle here. Imagine a bunch of squares. Look at, I'm going to draw the squares in here. Inside the circle. Look at all these squares. That's how it kind of look. That'd be 379.14 square centimeters inside the circle. That's the area of the circle. It looks something like that. You see? That's kind of what you're thinking about when you're thinking about area. Okay, here we go. We're not done. Let's not get all happy yet. We only found the area. We got to find the perimeter now, but remember the perimeter of a circle is called the circumference because it's made up of pure curve. Now, the circumference formulas, you have two to choose from. This formula table gives you two to choose from. You choose the one you want to work with. I grew up with this one, 2 pi r. 2 times pi times the radius. Some people prefer the pi times the diameter. You choose the one you like, I can care less. I'm going with the first one, 2 times pi times radius, because again, like I said, I grew up with that one, and it's got sentimental value. So let's find the circumference of this circle now. Here we go. So remember the radius of the circle was 11 centimeters. Circumference in Dodger blue is 2 times pi times the radius. There's a formula. Circumference is approximately 2 times 3.14 times 11. So regular centimeters. That's how many centimeters are around the circle. Nice, nice, nice. So we use the circumference formula, 2 pi r. Again, you could have used circumference equals pi times the diameter. Either one, you still get the same answer, just a little FYI.